One of NVIDIA's new DLSS 4 features include multi-frame generation. You know, the feature that quadruples your FPS and gives an RTX 5070 the same performance as RTX 4090 at a 1/3 of the price. From a game developer's perspective, this idea of quadrupling your frame rate isn't as crazy as it sounds. And no, I'm not talking about the usual performance tweaks like optimizing graphics settings or turning off fancy effects. I mean, literally quadrupling your FPS without touching your graphics at all. That is, if we are just quadrupling our FPS. So, how is this possible? In order to understand this concept, let's break down what frame rate really means in games. When we talk about FPS, or frames per second, we're basically talking about two things happening at once. How often the game logic updates, including how often it captures players' input, and also how often it renders new images. So at 30 FPS, your game is capturing inputs and rendering new images 30 times a second. Here's the thing, rendering those images is by far the most demanding task in most of the games. So what if we could split these two jobs? What if we could handle player input more frequently while keeping the heavy rendering at a lower rate? That's exactly what we're going to do. Because the truth is, sometimes we don't actually need the GPU to render 30 times per second to have a smooth motion. Now the problem here is, how do we keep the visuals smooth if we are only rendering 30 new images each second? And this is where the magic comes in. When you move your camera in-game, the game knows exactly how you're moving, the direction, the speed, everything. Instead of waiting for the next full render for the image, it takes the last frame and cleverly shifts the entire previous image based on your movement. Think of it like taking a photo and precisely sliding it to match your camera movement. But this is done with perfect precision based on your actual input. And this looks, as you can see, very convincing. The asynchronous part is what makes this really clever. While your GPU is working hard to render the next full frame, a separate process is handling these quick image adjustments. And this is exactly what gives you smooth motion even between the fully rendered frames. And that's called asynchronous reprojection, a smart way to get smoother gameplay without making your GPU render every single frame from scratch. Surprisingly, this isn't some brand new innovation. It's a concept that's been used in VR for a while now. Why? Because VR headsets, especially ones with mobile chips, can't consistently push out 90 FPS, and they need a workaround to avoid making players sick. Okay, well, now we just figured out one method to quote-unquote quadruple our FPS. Now let's talk about frame generation or interpolation. In order to understand this, let's first break down how frame generation or interpolation works. Basically, you probably already know this, and it's about creating new frames between two existing rendered frames. And while any graphics card can technically do this, what matters is how these frames are created or interpolated. What does this exactly mean? An interpolation is basically how you smooth a value from A to B. Now, let's try and understand this in a very simple abstract example. This is how it would look like in a graph. X-axis represents time, and the Y-axis shows our value. Without interpolation, we'd jump straight from 0 to 1. But with interpolation, we create a smooth transition between these values. The simplest version of an interpolation is linear interpolation, where we draw a straight line between points. But we can also use fancier methods like spherical interpolation, and this just transitions differently. And this same concept applies to pixels and entire images. The way how NVIDIA's DLSS 4 frame generation works is that instead of using a mathematical formula for the interpolation, we're using an AI for the interpolation method. In other words, an AI would generate a picture that would best fit between two rendered frames. While rendering the original frames takes significant GPU power, calculating the interpolated frames can be relatively quick. And that's why NVIDIA packed better AI cores into their RTX 50 series cards, making them much faster at frame generation than the previous DLSS 3. What's also important and might be a common misconception of NVIDIA's DLSS 4 technology is that while you could use AI to generate frames in between, what you could also do is go a little bit more low level, and for the values that are very difficult to calculate on your GPU, you could also just let an AI estimate this value. And this is exactly what ray reconstruction is by NVIDIA. Ray tracing is probably one of the most demanding rendering method, and calculating a ray bouncing from a camera's point to every single object in the environment takes very long time. If you guys want to learn more about ray tracing, I can definitely also make a video about that. Now, previously I've mentioned you could take any interpolation method for frame generation. Say we're taking a linear interpolation that I've showcased earlier. Now, you might think, why not just use simple interpolation to turn 30 FPS into 100 FPS? You could, but the result wouldn't look great. Here's a game that's rendered in 30 FPS, but linearly interpolated to give me 1000 FPS. There are a lot of ghosting and awkward motion happening, and that is why having a sophisticated interpolation method is crucial for gaming. Here's where things get interesting. Some of you might have noticed a catch. Most interpolation methods need 2 frames, a starting point and an end point. This means we can't show an interpolated frame until we've rendered the next one. Why does this matter, you might ask? In games, inputs are captured every frame. Higher frame rates mean more frequent input capture, which reduces input delay in the end. So if you're using interpolated frames to turn 60 FPS into 240 FPS, you're essentially getting 30 FPS worth of response time. Sure, the image looks smooth, but you might notice some delay. And this is why using interpolation to quadruple your FPS might not be good. Also, quick side notes, the benefits of lower response times also follow a law of diminishing returns. The jump from 10 to 30 FPS is huge, but the difference between 120 and 240 is much less noticeable. To solve the problem with higher response times, this is where extrapolation comes in. Unlike interpolation, extrapolation tries to predict future frames based on current data. This is actually what asynchronous reprojection does. It uses players' input to guess and generate the next frame without actually waiting for the actual next frame calculated by the GPU. The benefit of this is that, obviously, we're not sacrificing on our response times. The downside is, of course, we're working with limited data because we can't have anything beyond the original frame rate. We can also therefore see some more visible artifacts. Oh, and as a bonus, NVIDIA's new Reflex 2 technology also uses asynchronous reprojection principles to reduce response times. Since it captures input at a higher frame rate, you get better input response overall. This has been Semi-Coder. I kind of know how to code.